I know there's people in the room who can't factor, and you haven't done anything about it. You're ignoring it, like the check engine light. Okay? When it gets brighter, it'll probably mean it's ready to be dealt with. I'll take it in. Until then, it's all good. If you don't know how to factor, it's going to be a challenge for you. Okay? We've talked about the different steps of factoring back in the beginning of the class, the very first and second days. There's a great factor review. It's as comprehensive as you could ever need. If you don't have a method, you need to go and visit that first chapter, first file factoring review. And then if you want to see stuff in terms that are similar to those notes, go to the GBHS shorts, math shorts, and check those. We're looking at different kinds of polynomials here. Monomial means one term. Binomial, 2 terms. Trinomial, 3. We're talking about number of terms, and the terms are separated by plussing or minusing. When we talk about roots, we said another name for roots is what? There's 2 other names for roots. What are they?
Square.
Nope. They're in your notes on Friday, hopefully. Roots, what are they? 2 other names. Zero, what is an x-intercept? What are those things? Roots, zeros, x-intercepts, what are they? Who's they? Or more generic. More generic. Begins with G, ends in graph. The graph. Where the graph crosses the x-axis. How are roots, x-intercepts, and zeros named? How do we name any of those 3? They're all the same. How will I know that something is a root? What will it sound like? Nope. What is it? Something, comma, 0. If it's an x-intercept, it's got to be something, comma, 0. That's where we get the x-axis. Roots are the solutions to a quadratic equation that's set equal to 0. Roots are the solutions when the equation is set equal to 0. In this case, a quadratic equation set to 0. What is the 2 called in a quadratic equation? It is a power. What's it called? Begins with D. Ends in degree. It's the degree. What does that tell you? It tells you how many roots there are. So if the highest power is a 2, there's 2 roots. If the highest power is a 3, there's 3 roots. If it's a 4, there's 4 roots. How do you find the roots? Yeah, but if I give you a function and I want you to find the roots, that all you have to do is what? Before that, you're taking it for granted. How do you find it? You plug in 0 for y. And that's for any function. If you need the x-intercepts, plug in 0 for y. That's what we're telling you right here. Roots are the solutions of a quadratic equation, or any equation, that is set equal to 0. If you're not paying attention in here all the time, you're going to miss these details. You're going to be incredibly frustrated with the way the questions on the test are worded if you don't know what the words mean. Because I'm going to ask you for the x-intercepts, for the y-intercept, for the vertex, for the roots. And you have to know how to find them and what they mean. If I ask you for x-intercepts or roots or zeros, what will your answer sound like?
Y. What 0 or
Yeah, much, almost there. Yes, and what will it sound like? Something comma 0. The y for sure has to be 0. All right? In your factoring, you need to know how to factor quadratics that are difference of two squares. You need to know how to factor out our perfect square trinomials. And you need to be able to factor factorable trinomials. And I expect every single one of you can already do this. Here's 4 that you should be able to factor right now. All right, Andrew, you can pick whichever one you want. Tell me how it factors.
For A, I got x plus 6, x plus 8.
Excellent job. Jagger, how about one of the other 3 remaining? You can have whichever one you want.
X plus 5x, or no, x plus 5, x plus 4.
So that's B. Okay. Cole, you got 2 to choose from.
C is m plus 11.
That's a difference of 2 squares. Step number 2. M plus 11 times m minus 11. Good so far? Okay, we'll take a volunteer for the last one.
Is it p minus 12 and p minus 12?
Or p minus 12 quantity squared. Very good. That one is a perfect square trinomial. And if you don't recognize that as a PST, you really want to review that. This will, knowing this, will save you a boatload of time in this class. So you want to make sure you can recognize PSTs. Any questions on these 4? Factoring, by definition, I guess, is changing a sum or difference problem into a multiplication problem. That's all factoring is. Solving is finding the values of a variable that makes an equation true. Can I ask you to solve this? Why not? There's nothing to solve for because there's no equals. So we can't solve it. Can I ask you to factor it?
Yes.
Absolutely. But I can't ask you to solve it. How does this factor? How does this one factor?
X minus 7, x plus 6.
Thank you. X minus 7, x plus 6. It should be instantaneous. If this is a difficult problem for you to factor, we've got to do something to get you up to speed. When you are solving and you have a polynomial, in this case a quadratic, we change it to a product. Why do we change it to a product? Why do we want this x squared minus x minus 42 to be x minus 7 times x plus 6? Why do we want that? But how is it that we can't get 2 from this? I mean, there's definitely 2 for this, but I don't know how you're going to get them unless you're going to do just the check. What zeros? It is in intercept form, and we did kind of think that maybe y is the 0 kind of thing, although it's not a y equals situation. And so we don't really have x-intercepts, we just have solutions. But you're on the right track. Why did we teach you to factor? Why did we teach you that something times something equals 0? Why do we want that? Right here. Yeah, what is that? Zero product property. The zero product property tells you that if you have something times something equals 0, what has to be true? One of the blanks had better be a 0. Right? There's no way you could put something in this blank and something out in this blank, and neither of the blanks have a 0 in them, and this would be a true statement. There's no way. And if there is, you should share it with everybody, and you can have an A for the class. Okay? That would be cool. You'd be a revolutionary. But there isn't a way to do it. Zero product property says take x minus 7, set it equal to 0, and take x plus 6 and set it equal to 0, and solve. What's x equal? -7 and -6. Your answer is 7 and -6. No parentheses and no comma zeros because we're just solving. Again, really important to know the difference. If you write 7, 0, -6, 0, we're going to take off points each time. Okay? The roots, the x-intercepts, the zeros. Roots, x-intercepts, zeros, they're all the same thing. It's the place where a graph crosses the x-axis. We talked about it briefly on Friday. It's where the graph crosses the x-axis. It might have been Thursday. They are always something, comma, 0. X-intercepts means y is 0. What does a y-intercept mean? Zero, comma, something. It means that x is 0. X-intercepts means y is 0. Y-intercept, x is 0. We're not usually concerned about the y-intercept. That's not to say we can't find it. We're just not normally concerned. How do you find the x-intercepts?
Plug in 0 for y.
Well said. Plug in 0 for y. How do you find the y-intercept? Plug in 0 for x. We talked about this when we graphed lines. Here's an equation written in standard form. Y equals. Here's the same equation written in function notation. F of x equals. Same equation. No difference. One is in a different kind of a notation. That's the only difference. In Algebra 1, most of my kids struggle with the idea of function notation, and as soon as you see this in Algebra 1, they just change it to y, and then they feel better. In this class, you have to learn to work in function notation. The function notation usually is referring to the name of the function, in this case f, which probably means nothing. The variable in question is x. When you plug in an x value, you get an f of x value. Your ordered pairs are x, comma, f of x, not x, comma, y. Regardless, you put y in either for a 0 in either for y or f of x when you're trying to find the roots. So your roots are 7, 0, and -6, 0, which you guys already determined. To find the roots, plug in 0 for y or 0 for f of x. Again, I'm not putting in a 0 for x. I'm putting it in for all of f of x. Okay, try B and C here. B and C. We want to find the solutions. Unless this is find the roots. Find the roots. So if we're going to find the zeros, we factor. And you're going to get x plus 7 and x minus 4. If I want to find the zeros, what do I put in for y? 0. So x is going to equal -7 or +4. So my roots are going to be -7, 0, and 4, 0. Does everyone see the difference between these examples and these examples? How it's a bad question to ask for roots here, but not here. Is anyone not seeing the difference between them? Because this is a really important distinction. One variable versus two variables. This has only one, just the x. You can solve those. This has two. We can find the x-intercepts, roots, or zeros because that's a function you can graph. The B question here is a PST. Y equals x minus 2, quantity squared. That fast to factor. If you can't factor it that fast, you are behind. Look, I want it to be easy for you. I want you to know this stuff, and I want you to have success. And I'm telling you, these are the things you need to do. Make the note cards. Learn how to factor. Study every night. And you're giving me back in return, Miss Audrey, it's the weekend. I don't study on the weekend. When we were at Calvert, they said no homework on weekends. Oh my gosh, why are we still having homework? You guys have to do the work to get to this level. Then take the rest of the time off. But if you're not studying, you're not making flashcards, Chapter 4 is going to kick your fanny. We're multiplying. 1 times -6, finding factors of 6 that subtract to give you 5, and then we're factoring. So we're going to get x plus 6 and x minus 1. If we're going to put in a 0, x is going to equal -6 or 1. The roots are -6, 0 and 1, 0. If factoring is a problem, you need to resolve that. And you need to do it right away. How does this factor? How does this one factor? It can't. There are no factors of 5 that add up to give you a 3. So we are without the ability, or we were without the ability to find the x-intercepts or roots or zeros. Remember, this is a degree 2. Does anyone recall what I told you about the degree and what it tells you?
How many factors? How many roots? How many roots are?
How many roots there are going to be for x-intercepts. This is a quadratic. There's 2 x-intercepts, potentially. Is there a way that we could have 1 x-intercept?
Yeah, it's right on.
If it went right down and kissed off the x-axis. When will that happen? When you have a perfect squared trinomial. Okay? The only root here is going to be 2, 0. Now for the bonus question on that, what kind of a root is 2, 0? Ooh, it is a minimum. Good call. But that's not what kind of a root it is. That's the kind of a function it is, but really good.
Vertex.
It is going to be the vertex as well. This is going to be the vertex, and it's called a double root. The reason why it's a double root is because you could write it like this. And you would see that 2, 0 would be an x-intercept twice. And it's called a double root. When you get a double root, it's going to be tangent to the x-axis at that point. The graph will come down and kiss the x-axis and bounce off. Or it'll go up and kiss off the ceiling and bounce back down. Okay? But we also have ones where we can't factor. So you learned in Algebra 1 the quadratic formula. The quadratic formula, I don't know what your Algebra 1 teachers did. I put it up on the board in chapter 10 or whatever the chapter is where we do this. I put it on the board. It's not going to be on the board here. So you're either going to have to cheat or learn it. It never goes away, so learn it. It's not really that complicated. Okay, but you have to know the quadratic formula, and then it's plug-and-play math. My feeling on the plug-and-play part is that as long as you give me this, as long as you show me this plug-in with nothing simplified, you'll get partial credit. If this is not shown, if there's a 9 right here, or a 20 right here, and you do it, you get the answer incorrect, then I will give you 0 points partial credit. This is a non-negotiable step for me in the quadratic formula. So we have x equals -3 plus or minus 9 minus 20 over 2. So we get the ugly -11 under the radical. What does that tell you about your roots? Square root of -11. What is that telling you? Square root of negative anything. Of course it's possible. Have you really not been exposed to this? Is that possible? No way. In Algebra 1, don't they teach you this stuff? They didn't teach you nothing. I just stay in there and I don't do nothing. I guess they're going to let you off without that happening. All right, so you're not going to have any where this occurs, where this is a negative. So you're not going to have to worry about quadratic formula. That's where we were, right? You're not going to have to worry where you get a negative today under the radical. Okay, so you won't have to worry about that. Okay, try this one with quadratic. Just, you can do quadratic. X plus 7 and x minus 4. Okay. If we put in a 0 here, what would be the x values that would make this true? What is it, Bryce?
-7 and 4.
-7 and 4. Aaron, can you tell me where I'm going to find the vertex? Not -7/4. How do we find out where the vertex is going to be? You remember? That's at 4. -7.
Add 4 and -7.
So what am I going to get? -7 plus 4. -3 over 2. How do I find out what the y-coordinate vertex is?
Plug it back into the
Plug it
original.
back into either. I mean, you could do factored, but I always go back to the original.
I was like,
It's not -3.5. Squared would be 9 over 4. Top squared, bottom squared. Use a calculator if you have to. There are people in here who could not do anything with fractions if their life depended on it. I'm going to give you $1 million if you can add these fractions and multiply these fractions. Can't do it, sorry. I'm okay with that. Plug it in. I'm not okay with you not being able to do it without a calculator. Now, difference of two squares. X squared minus 121. If we factored it, what do you call this? What do you call that in red? No, that's how it factored. This is a difference of two squares. What do you call this in red?
Factor.
What's this called in green?
Oh, that's intercept form.
This is intercept form. This is parabolic form. What's the vertex? 0,
21. -121.
negative 121. This one tells you the roots, the 11 and the negative 11, comma 0. This green is found just by writing x as x minus 0. That's all I did. Nothing revolutionary, nothing transformational. All I did was rewrite it so you could see, hey, that's parabolic form.
Technically, could you also do plus 0?
You could, but the form says y equals x minus h squared plus k, and then the k is going to be here, but it says x minus h, and that's why I put minus. I don't care. Okay, honestly. But if I just don't want to confuse people and put plus and then them say, well, you said it was supposed to be minus h. Whatever, it's 0. Okay? So instantly you know the vertex, instantly you know the x-intercepts or the roots or the zeros. This is a PST. What do you know about PSTs? The graph will always be tangent to the x-axis at the vertex.
What is tangent?
Tangent means it will touch only in one point. So if you have, back in the days of geometry, you may remember having a line in a circle tangent, they touch in only one point. Or a circle in a plane touches in only one point. Look at that. Okay, but what we mean by tangent is touches in only one point. Right? The vertex is called a double root, and that will be true anytime you have a PST. If you can't look at this and say, hey, this is x plus 9 quantity squared, it means you don't know how to do step 3 to factoring. That means you're not studying. That means you get to take this class in the spring. What's the vertex? Minus 9 or negative 9 comma 0. So 1, 2, 4, 6, 8, negative 9 comma 0. What's the vertical stretch factor? Right 1, up 1. Right 2, up 4. Left 1. And left 2, up 4. Here's your graph. And your tangent to the x-axis at the vertex of negative 9, 0. That root is called a double root. Whenever you kiss, whenever it comes down and kisses, it means tangent, it means it's a double root. Or it could be a quadruple root, but for our purposes, in quadratic world, they can't have 4 roots, they can only have 2. When the graph is tangent, you have a double root. The last thing is you're going to have to apply some of this stuff. For these, this is called a border problem, like a picture frame. Or you have a pool and you want to pour a concrete walkway around the pool. Or you want to plant roses around your grass or whatever. You're going to have a border. You're going to have an outside shape and an inside shape. And the area of the outside shape minus the area of the inside will always equal the area of that border or that frame or whatever the thing is that goes around. And sometimes it only goes partially around. So you might have like this, and then you might have the border do this kind of thing. You still have an outside shape and an inside shape. This still applies.
What is the area? What is the area of the border? It's not the same. As
That would be the area of the frame.
So both of the inside and
Nope. If I'm going to paint the frame, where would the paint go? Would it be in here?
no, it'd be around.
It would just be on the wooden part of the frame.
So it would not be the same as the area of the outside.
If I find the area of this rectangle, am I including where the picture goes? Aren't you?
We're finding the
If I want to find this rectangle's area, aren't I doing this?
area. And then you're
And then I'm subtracting the inside shape, and that leaves me with the border.
Isn't it a square?
Isn't what a square? When you say that, what are we referring to?
The inside?
It could be,
Because it's two on both sides.
but if it's a square, can I still call it a rectangle?
Yeah.
I don't want to get caught up in semantics. In this case, they're talking about 2 feet by 2 feet. The outside definitely appears to be a square. And it's the same measurement in the border. Oh, it's 2 feet by 2 feet on the inside, x by x on the outside. So x squared minus 2 squared equals the area of the border squared, a of x. So you have x squared minus 4 equals the area of the border. If you want to find out what the length of the sides of the frame would be, if they tell you the area is 5, x squared minus 4 is 5. How do I solve for x? Add 4. And then what? Square root. Be careful. Plus or minus 3. As far as the algebra is concerned, this is a plus or minus 3. As far as we're concerned, what's the answer to the question, what is the length of the sides of the frame?
3 feet.
The length of the sides of the frame. Give me the dimensions. 3 feet by 3 feet. So the dimensions are 3 feet by 3 feet. If you do not answer a word problem with words, you will lose a point. If it's a word problem, your answer's in words and numbers. Whoops. You already saw the video. Here's what you're doing for homework.